Hello everyone, welcome to the last video lesson for the semester, and we're going to be talking about the Big Bang Theory. So for this lesson, we're going to be able to explain the Big Bang Theory along with its evidence, as well as provide a timeline for the known universe. So before you start this lesson, make sure you also watch the video I linked before, either on Schoology or on this the description. It goes over the difference between a theory and a scientific theory. The main things to know about scientific theory is that it's a theory that is usually backed with evidence that does not disprove it. So let's talk about the age and size of our universe. So our universe is estimated to be about 13.7 billion years old, which is almost 14 billion years old. And it's estimated that the known universe is approximately right now the length of 46.6 billion light years, but it's still expanding. Light years, if you don't know, is just the distance light can travel in 1 year. So the Big Bang Theory, what it says is that the universe expanded from a single really hot point from a giant explosion. And as of today, the universe continues to expand. So we're not talking about the show, we're just talking about the Big Bang Theory. So I'm going to provide a timeline for the origin of our universe. So in the beginning, let's just call this at 0 seconds. Everything was compressed in a very small point where there was a large amount of density, so all the mass was compressed in one small point. Then 10 to the negative 43 seconds after, so that's a very small amount of time, the universe reached, the Big Bang occurred, and then the universe was at 10 to the 32 Kelvin. So, like the song of the Big Bang Theory, which I'll play right here.
Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait.
And I'll stop there, just to, because I'm not sure, but I'm pretty sure that song will be copyrighted. Okay. So now 10 to the negative 38 seconds after the Big Bang, the universe starts to expand greatly, and then gravity starts to be developed. There's this theoretical particle called gravitrons that is what causes gravity to occur, the force of gravity. It's not physically or visually known, but it's a theory that it's out there. Then 10 to the negative 12 seconds after the Big Bang, we start to have the four fundamental forces that are separated, and then particles are formed. Remember, the four fundamental forces are gravity, electromagnetic force, weak nuclear force, and strong nuclear force. So now, 3 minutes after the Big Bang, the temperature of the universe is approximately at 1 billion K, and then the protons and neutrons begin to develop and come together to form a nuclei, specifically a helium nucleus. Then after 380,000 years after the Big Bang, the temperature reduces to 3,000 Kelvin, and then electrons are able to be formed and join the nucleus in order to form the atom, what we know now. Then 300 to 500 million years later, after the Big Bang, stars have been formed, and then they're been going over their lifespans and develop supernovas and different types of explosions. And these explosions, as we talked about in our stars and star lessons, they cause a lot of nuclear fusion, and different elements heavier than carbon begin to be produced. And we're not talking about elements such as fire, earth, wind, and water, like thinking of Avatar, which is recent, but the elements of the periodic table. Then 9 billion years later, our sun has been formed, and then a previous explosion from a previous star is what makes up the planets of our solar system. Then this is right now, 13.7 billion years later. The temperature of the universe, when it's not near around stars or anything like that, it's 2.73 Kelvin, which is almost absolute zero. But expansion continues for the universe. So you can see the picture here. This is where the Big Bang started, and it just keeps on expanding outward. So I want to go over the different types of evidence for the Big Bang. There are three main things. We're gonna focus more on the evidence on a different lesson, but this is just a brief overview of them. All right, so the first one is called Hubble's law. So Hubble's law, this law states that galaxies are moving away from each other, and then the farther the distance, the faster their velocity. So the farther the distance compared to our galaxy and other galaxies, the faster they are moving. So if we talk about this mathematically, that means at some point an explosion had to occur, or a single point had to be where the universe started expanding, and then it just keeps on expanding from there. Next one is cosmic microwave radiation. So Arno Penzias and Robert Wilson, back then around, I believe, 1960, with their telescope, they discovered some radio signals using their telescopes that are in all directions of the sky, whether it was during daytime, nighttime, whenever, and they were in the form of microwaves. So when the Big Bang occurred, of course, there'll be a lot of radiation, and microwaves are usually in the lower end of the radiation, so the fact that there's still different types of microwave signals in the universe or space, these are proposed to be left over from the Big Bang. So that cooled off. Basically, the billions of years of cooling caused the microwaves to still be around in the universe, and this helps prove that the Big Bang occurred, because these microwave signals still appear out of nowhere, and they must have started from some point. Finally, is nucleosynthesis. So this is talking about mostly the type of elements that are present in our universe. If you were to research it, you'll find that the most common element of our universe is actually helium. And when we talked about, remember the star lesson, helium is produced from a fusion of hydrogen. So helium and other elements are formed by stars by their supernovas, or just the nuclear processes inside them. So there must be a point where all of these elements start. Remember that the universe started as the Big Bang proposed, that it was a hot, dense state, that's like the song, but Big Bang Theory says, where an explosion occurred. This is similar to like a supernova from a star. Remember, think about that. When a supernova or red giants occur for a star, they start to run out of hydrogen to fuse, and then the helium starts to fuse into bigger elements until there was too much mass that has to explode. So the findings that helium is the most common element of our universe, it kind of goes into the theory that the universe started with some sort of explosion if it was similar to the formation of a star. Because as we know, stars are usually where our elements of the universe come from. So this is another evidence to help prove, or just, it doesn't disprove the Big Bang Theory. All right, and that's it for evidence for the Big Bang Theory, and then also going over the Big Bang Theory itself. This is mostly about giving a general description of the Big Bang. The next lesson we're going to focus on, it won't have a video, but you're going to be able to make an argument of why the Big Bang Theory is a commonly accepted theory using evidence from different articles. So we'll work on that later this week. Right. Thank you, and this will be the last video lesson for this semester. Right. Thank you. Bye.